Antimatter has played a key role in science fiction over the years, but what you may not know is that it actually plays a very important role in real science as well. There are two main building blocks to the universe. There is matter, as depicted here excellently by my friend Rohit, but there is also antimatter. Let's look at a quick example. On the left we have an electron, and on the right we have its antimatter counterpart, the positron. For each particle in the universe there is the equivalent antiparticle. It tends to be that the properties of the particle are opposite to that of the antiparticle. The electron has -1 charge, the positron has +1 charge. In the event of a collision between matter and antimatter, an explosion of energy occurs. The explosion takes the form of a photon, i.e. light. The energy of the photon equals the energy of the matter plus the energy of the antimatter. In other words, basically 2mc². This is calculated by Einstein's theory of relativity. 2mc² is loads of energy. In the Big Bang, both matter and antimatter were produced in equal amounts. Most of it exploded instantly. However, luckily for us, in our section of the solar system, there was more matter than there was antimatter, and so life evolved, planets formed, you're sitting here unexploded. Let's look at exactly how powerful an antimatter-matter explosion is. This is a nuclear fusion reaction, the type used in atomic bombs. If the same amount of matter and antimatter were used as there is nuclear material, this explosion would be 1,000 times greater. So if there's so much antimatter in the universe, how come none of it has ever, by chance, come into contact with Earth? How come we've never seen a random explosion like that before? Well, in 1908, 1,000 miles east from Moscow, a farmer saw a massive explosion, the scale of which had never been seen before. It couldn't have been nuclear weapons because they simply hadn't been invented before. This is Paul. Paul is the person who came up with the idea of antimatter. He tried to improve the Schrödinger equation, and now he feels epic. You may have heard of Schrödinger and his many cats, but what Schrödinger is most famous for is developing modern-day quantum physics. The physics whereby nothing is certain, you can't be sure of anything, and basically physics doesn't work. This is the universe. Paul, from his equations, realised that in every vacuum in the universe, there must actually be a sea of infinite negative energy. No, not that type of vacuum. Paul said that we didn't actually notice this infinite sea of negative energy though, because it was everywhere. There is actually one time that we would notice it though, if it was zapped with enough positive energy to turn some of it into a positive energy state. This would leave behind a hole that acted exactly like a particle, and also the physical particle itself. And so antimatter and a greater understanding of our universe was first postulated.